Hi guys, how are you? Today I am here with an interesting question which came into CSIR-NET June 2019. June 2019. So this is a ketone which is treated with CY2 dicyclohexyl boron chloride in T triethylamine. T is triethylamine and then ETCHO. The product A is formed, and in another reaction, in presence of LDA THF minus 78 degree centigrade, ETCHO, product A is formed. So in two conditions, what will happen? So you can imagine that this reaction is an example of aldol reaction, stereoselective aldol reaction. So this ketone, which has alpha hydrogen atom, is treated with a base, and if it is treated with the base, the enolate will be formed, and this enolate will further react with another molecule of carbonyl compound to form an carbon-carbon bond, and the product B is formed, and aldol will be the product. So what will happen here? We can see that CY2BCl, in presence of CY2BCl, mainly what will happen, E enolate will formed. E enolate. How E enolate will form we will discuss, and in presence of LDA, mainly Z enolate will form. So we will first discuss this pH double bond O. Here is a hydrogen. LDA is lithium diisopropyl amine. This is LDA. Here Li plus. So it will take that proton, and the corresponding enolate will form. O minus Li plus. Sorry. So the corresponding enolate will form. Here methyl group will be in this side. So this is Z enolate, and if it is treated with ET C double bond OH, then an carbon-carbon bond formation reaction will take place, that is an aldol will form. So the product will be PHC double bond O. Here there is a methyl group, here there will be OH group, here there is a ethyl group, and in another reaction triethylamine, here 2 cyclohexyl group is there, triethylamine, it will take this proton minus Cl minus. So what will happen? Here also an enolate will formed, but OBCY2, here the methyl group will be in this side, so E enolate will formed. Why E enolate will formed? Because this BCY, it is a very bulky group, and the methyl group and this group will not be in same side, so CH3 group will be here. If it is treated with ETCHO, then the product will be same, ETOH CH3. Now we have to determine the stereochemistry of this CH3OH group in these two products. So we cannot we don't know what is the stereochemistry of the product of this product. So this can be determined with the help of some transition state. If we see the reaction, this reaction go through a 6-member cyclic transition state. Let's say we can represent an E-enolate like this. O, here say R1, it is R2. This is an E-enolate. O minus, and the Z enolate is O minus R1 R2. This is Z enolate. Now if these two treated with a carbonyl group, the transition state will be like this. I am drawing this for Z enolate. For Z enolate, this O minus and R2 are on the same side. Here is R1. And the another possibility is here will be a metal ion. The another possibility for this is for Z enolate. Another possibility for Z enolate is like this. Here the R group will be in axial position, hydrogen will be in equatorial, and the remaining will be in the same position. Here hydrogen is there. Now you can see that this R and R1 both are in axial position, so there will be some steric crowding here. So this is less favored. This is more favorable transition state. Now if we draw the same transition state for E enolate also, then what will happen? For E enolate, we will draw the same transition state. For E enolate, here the R2 and O are on the same side, but here R2 and O in opposite side. So here will be R2 and here will be H for E enolate. Here will be R2 and here will be H. R1. Now in one orientation, the hydrogen will be in axial and Another orientation is also possible. Here R will be in axial position. R1, here hydrogen R2. So this is another transition state, but in this transition state there will be a steady crowding between R and R1. So this is less favorable, and this is favorable. Now from this transition state we can see that here this R2 group and this O will be converted finally to OH group, an alcoholic hydroxyl group. So this R2 and this OH are on the same side, that is below the plane. This is also below the plane, this is also below the plane. This is in same side in favorable transition state. But for E-enolate, the R2 and this O are in opposite side. R2 in above the plane and oxygen is below the plane. It is coming down, so it is below, and it is going up, so it is above. Here it is coming down, so it is below. It is coming down, so it is below. So from this transition state, what will be the product? The product will be, so it is Z-enolate. The product will be ET double bond O pH. Here this is the R2 is here methyl. We can see here R2 is in below, so R2, and here OH also below. So for Z-enolate, the R2 and OH will be on the same side, and from this favorable transition state, what will be the product? There will be T double bond O pH. Here R2 is above, and OH will be below. So these two are in opposite side. So you can see here that from this transition state the product will be like this, and from this transition state the product will be like this. So for our in our question the R2 is methyl and R1 is phenyl. So we will replace this R2 with methyl and we will get the product. So in our question the product will be, if R2 equal to methyl, then it will be CH3, it will be OH. And here also if R2 equal to methyl, then the product will be here will be a CH3 and it will OH. So this will be the product. This is here these two group are in opposite side, and here these two group are in same side. So guys, if you have any doubt regarding this video, please let me know in comment box, and to get more such interesting videos, subscribe my channel. Thank you. Have a good day.